Hello, everybody. My name is Damien Alexander from SQF, and welcome to our environmental air testing what, how, who, when, and where webinar for the 20th of March 2025. Before we get started and before we introduce our guest speaker, I'd like to touch on our FMI SQF antitrust statement. So please take a moment to read our antitrust statement. If you have any questions or concerns regarding any conversations we may have or anything regarding the antitrust statement, or you'd like a copy of it, please contact info@sqfi.com or likewise contact myself. And under our antitrust statement, we must comply to all antitrust, anti-competitive laws, and as such, discussions regarding price fixing, market allocation, boycotts, refusal to deal with third parties, etc. We will not be doing that and cannot do that. So thank you for that. That's some of the formalities out of the way. SQF. So this is our SQF BD team. And I just wanted to take the opportunity while I have the audience to introduce you to our business development team. So we're around the world. This is not the entire SQF team. Our role is to support and help businesses who are looking to become SQF certified and going along the SQF certification path and journey. So this is us, and that's me down the bottom right-hand side of your screen, based in Australia, and myself, Noriko, and Sarah. We look after Asia Pacific. Before I introduce Jonathon, I'll just touch on myself. We'll get that out of the way. So I've been with SQF for a few years now, and I've worked across the food industry in technical roles from production management, quality management, meat, seafood, poultry, insurance, retail, regulatory. So pretty much across the board, all around food safety. And I've been working it's in some degree across SQF from its inception back in 1995. So that's myself. I'm the host, and our guest speaker today is Jonathon Sauseda. So Jonathon, not unlike myself, has had a long career working across laboratories and in touching in the food industry as well. So he currently oversees the management and daily operations of Tri-Air Testing. And although he's based in the States, they have a laboratory in Burleigh Heads in Queensland, Australia. So prior to joining Tri-Air Testing, Jonathon was the project manager at Omni Water Solutions and was the laboratory supervisor for Joel Unlimited, where he was directly responsible for both laboratories in Texas and New Mexico, as well as planning and the implementation of on-site testing. So thank you, Jonathon, and welcome. Now, I'd also need to touch on is our guidance documents. So at sqfi.com, we have a large number of guidance documents covering lots of different areas that are of interest to the food industry. And I wanted to call this out early because we have some guidance documents on ambient air testing and likewise air and other gases. So whether you're SQF certified, looking to become SQF certified, or certified to any other standard and so forth, an auditor, consultant, I thoroughly recommend you have a look at those guidance documents. They're free to download. They're not auditable documents. They're not auditable as per the SQF code, but they are guides. And there's some great information in there. And some of the information we will be touching on today is actually coming out of those guidance documents. Now, our topic, environmental air testing. We've chosen this topic for a number of reasons. I have personally seen in industry there's some confusion over what environmental air testing is and what to test and how to test and so forth, and what are the potential risks and hazards, and hence why we've invited Jonathon along as a technical expert to come and talk about that and how that is actually conducted. But when we're looking at environmental air testing, we're looking at potential contaminants, be it particulates or water condensation or microbial, so micro, physical, quality potential hazards that could become a food safety concern or risk to products. And well, compressed air and environment has the potential to contaminate food or reduce the quality of food, reduce shelf life, particularly if you're looking at things like molds and fungi. So how we manage it and how we test for it is something that is always quite topical and always a bit of an unknown across the food industry. So we're here today to explore that. Environmental air testing can incorporate allergens, but for the sake of this webinar, this presentation today, we're going to be focusing on particularly microchemical and physical, so micro pathogens and likewise spoilage microorganisms, physical such as rust, particulates, and chemicals which could be oils or contaminants from compressors, as an example, that could get onto food. We're not going to touch on allergens as part of this testing methodology, but we're going to certainly focus on all of the others. So without further ado, that's enough of me talking. Jonathon, welcome. Thank you for joining us today. Greatly appreciate your time and your input. Over to you.
Yes, sir. Thank you, Damien. Appreciate it. And thank you, SQF, for having me on. So as Damien said, I will talk a little bit about compressed air, ambient air, some different ways that you can test it, as well as trying to guide on specifications if you have specifications, or if you need to set specifications for your facility. So let's talk about what compressed air is, first of all. Compressed air, if you look at a couple of different ways of looking at it, or definitions of it, AI says that air, that's been forced into a smaller space, resulting in a higher pressure. We look at Webster Dictionary, it says air under pressure greater than that of the atmosphere. Pretty much what it is the air around you being compressed into a small area, and then that creates it pressurized, and then you're able to use it for your machines, for your packaging, for blowing down lines, tables, and things like that. And then what is ambient air? Ambient air is just the air around us, the air we're breathing right now. And honestly, what happens is the ambient air will turn into compressed air. So remember that, and we'll talk a little bit more further down on when you have issues with your compressed air and you're seeing stuff in your compressed air. That's a representation of the ambient air that it's pulling to create that compressed air.
Jonathon, quick question for you. What type of industries, and again, we're focusing on food safety, what type of food industries would you think, would you know of that are actually using compressed air for different types of processes?
So I see compressed air being used in all types of food facilities, from bottling, where they're creating the mold for the bottle, and then they'll use the compressed air to blow out plastic shards in the molding process. Then they'll put their beverage in the bottle. Then they'll use the compressed air for the headspace to keep the integrity of that soft drink. I see it on the packaging side of things where they're using the compressed air to blow open the bag prior to putting their product inside the bag, and then they're also using it in the headspace as well, to keep integrity, and that product staying fresh. I see it where they're using it on tables where they're blowing off debris or food particulate off the table, to clean it off before they start the packaging process or after the packaging process. See it on the capper side of things where they're capping the caps on bottles. So pretty much all over the food industry. I see it in the coffee industry, the dairy industry. So everyone's using it. And then as far as instrumentation as well, they're using it for some of these instruments to go ahead and be able to function and operate these different machines.
Sure. So even I guess in high risk environments where you've got positive air pressure as well, and sorting machines where they're using compressed air to blow off different types of products. So across the food industry, it's obviously compressed air is commonly used. So great, thank you.
And then how's compressed air created? So what happens is the compressor takes the ambient air around us, and it confines it, and it brings it into a small tank. We're going to see some examples in a little bit, but during this process, that it's being compressed, you have different things that are happening to that air. that ambient air while it's being compressed is becoming very hot. And that will create some condensation in the compressed air. You'll have particulate accumulating. Although we can't see it, normally you can see about a 50 micron size particle, and we're talking about 0.1 micron all the way up to 40, 50 micron. So you don't see the particulate, but particulate's being condensed as well. So you're introducing particulate in the compressed air at this time as well. And then, like we discussed, it's used, for surfaces, packaging, analyzers, and head spaces, and the different containers and packaging processes. And here's some examples of compressors that I've commonly seen on site at these different facilities. You have the bigger compressors, like the one on the left. The tank on the bottom is where the compressed air is held, and then from there it's blown to your points of use. Sometimes you have these smaller ones, like the picture in the middle of the smaller compressor, where that's usually, I've seen it on the packaging side where they're using an instrument for packaging. And then the one on the right is just another version of the one on the left. The one on the right, you can see at the bottom left, there's a little pipe coming out with a valve there. That's a good representation of a line that you would open that valve up during processing or during the day. Probably want to put a pneumatic valve or an automatic valve that opens up because that's a drain line. So during the cycle of it becoming compressed air, it gets hot, then it cools down to room temperature, and all that water just mounts up on the bottom of this tank. So you want to make sure that you're draining that line at the bottom to alleviate any water going through your piping system. Doesn't rust the inside of those compressed air tanks, which will cause more damage to your lines down the road. Rust and dirt, particulate. And so by using that valve and having your maintenance crew open that and close that valve, or having some sort of automatic system on that valve to open and close it during processing, you can really cut down on some of this. Particularly if you have lines that are older lines, galvanized or cast iron. Stainless steel, copper, not such big of a deal, but if you start introducing moisture, or you have moisture in galvanized piping or cast iron piping, you're going to create a lot of problems. You're going to create more particulate because that piping will start degrading over time. So you're going to have more particulate coming through your lines, which means at your point of use, you're going to have particulate coming out. And then you're going to have, water along with that, moisture coming through those lines as well. And potentially, depending on where that piping is in your building, and if there's heat around that piping and that piping staying cool or hot, you could potentially have some bacteria and mold and yeast forming in that piping, which would then come out at the point of use without the proper filtration. So you really want to try to keep those compressors and those holding tanks moisture free as much as possible.
I think that's a really excellent point, and a really good segue into the importance of preventative maintenance and maintenance. So, and if I was to go on site now and to have a look at a site, that's one of the questions I'd be asking for is, for your compressors, what are they made out of? Is it stainless? Is it and then checking the valves and releasing that pressure from the valve. How often is that occurring? How do we prevent moisture getting in? So it is a requirement. I'll touch on that towards the end of this presentation regarding preventative maintenance and SQF. So it's
it's one of those things that we're talking about maintenance is knowing your system. And when I say knowing your system is knowing the piping, right? What is from the compressed air to my point of use, what type of piping is that? That way you kind of know that way you do know the risk of it, as well as what type of filtration do I have? Do I have filtration that is moisture filtration only? Is it particulate filtration? If I have particulate filtration, what size micron are those filters? Is it 5 micron? Is it 1 micron? Is it 0.1 micron? Is it staged down? Do I just have filtration at point of use? And how often do I need to change those filters? All of that is stuff or information that is going to be very valuable for you to know, but knowing that will help you have consistent compressed air out of your point of use for your product by knowing that stuff. And if you don't know it, get with your maintenance team. And if you don't know the filtration, or you need to get filtration, you want to get with the compressed air testing or the compressor companies that you're using to help you figure out what you have or what you need and where to put them.
And Jonathan, with the changing filters at a certain frequency, I guess manufacturers will have set recommended requirements. And is that based on hours of use or volume?
Absolutely. They do. They'll let you know, and it's based on hours of use. So on these compressors, some compressors are used more than others, depending on the facility and how they're being used for, your compressed air is being used. And so on these compressors, there's actually a gauge on there that says hours. And that's the hours that compressor has been working. And so by getting with your compressor companies, and then knowing where to see it on these compressors, you're able to determine, hey, we used it for 50 hours or 60 hours. We need to check on this filter. And it's a lot higher than that, but that's just an example. But yes, the compressors are you gauge the compressor and the filter use by the hours of that compressor being ran and used.
Interesting, because I have seen in maintenance schedules, we will replace this filter every 6 months or every 3 months, but depending on the peak, how busy the business is, you change it in 3 months, it might be well outside the manufacturer's recommendation of hours per use. So that's a really interesting point. So yeah, know your equipment and know what you got in place and how to use it.
And then who needs to test, or who needs to follow these guidances for particulate, water, oil, microbial, and even your gas testing? As Damien mentioned earlier, SQF has those guidances, and in those guidances are different documents in there, and these are a few. And you'll see in the next couple of slides where it specifically tells you what you need to test. How often do you need to test it based on the guide that you are following for your programs, whether it's animal feed, primary plant production, food packaging, storage and distribution. This is where in the code it tells you what you need to test and how often you need to test it, and gives you some guidance. So if you're looking to know what you need to test, or if you're even qualified to test, or if you need to test, these are where it tells you in the SQF guidance or the SQF documents on where to test.
Yeah, so these are the requirements straight out of the code, absolutely. And then that, as you've mentioned quite rightly, is those guidance documents provide some additional guidance. The guidance documents are not auditable. These are the auditable requirements. But it's really coming down to knowing and controlling your potential hazards and your risks. Definitely.
And then how often do you need to test? And that really just, honestly, what SQF says is at a minimum annually. However, that doesn't apply for everyone. And when I say that doesn't apply for everyone, that's because first of all, you need to get a good baseline to figure out what specification you need to test. Not everyone in the food industry tests the same particulate, water, total oil specification. And we're going to go through the guidance in a minute on how I can figure out what I test, or where I need to test, what I can use for guidance, which is ISO 8573 is good guidance for the particulate, the water, and the oil. But you need to do a good validation, first of all, to determine a specification if you haven't done that. Some places already have specifications based on baselines or internal conversations of their risk. But at the beginning, you got to set up a validation testing, and we're going to talk about that in a minute. And then where do I test? Where am I testing my ambient air, locations? And so this also is very good to know where I need to test. Obviously, you want to test at your point of use where the air is coming out, because that's where it's actually hitting the product, the line, the packaging, the capper, all that good stuff. But you also want to test it upline. You want to test it, if you have 20 points of use, and your filtration, it's compressor, and then your filtration, and it's, maybe a 5 micron or 1 micron or 0.1 micron filter there. You want to test after that filtration or the original filtration before it goes downline to see if that filter is even working or those filters are working. And then you want to test down at the points of use, because that's where it's coming out, and that's what's touching your product. What I've recommended and what I've seen is a lot of customers out there is they do the validation testing. So let's say you have 20 points of use, you're going to test right after your original filtration, your filter, and then you're going to test a couple spots in between, and then you want to test at that furthest point that the compressed air is reaching. That way you can see and you can validate, hey, we're getting consistent air all across, from the closest line to the filter, to the lines in the middle, all the way to that last furthest point from the filter, and get you a nice good validation on some results, making sure they're all consistent. And then once you come up with that baseline of those results and you see that it's consistent all around, then you don't need to test all of them every time. You could test the one right after the filter. Always want to test the furthest away from the filter, and then maybe just one or two in between, to make sure that it's staying consistent in between, from the beginning to the end of your lines.
Excellent.
And then this is the guidance that I see a lot in the food. Even the pharmaceutical industry uses this to determine where they're at. And I'm going to break this down. If you can see the colors. So the particulates, the green, the water's the blue, and the oil is the orange. And so these are the three. These are the three that SQF says to test, along with mold and bacteria and high risk. So let's just break down the particulate first. If you look on the left-hand side of this chart, those are the different classes. So they go all the way from class 0 to 10. And if you look specifically at class 0 through 5, which most people, I haven't seen anyone in the food industry do a class 0, and all class 0 says is that it exceeds, and it's more stringent than class 1. But let's look at class 1 through 5. If you look at that, if you look above there, you're going to see 0.1 to 0.5, 0.5 to 1, and 1 to 5 micron. So what you're doing with a class 1 through a 5 is you're actually counting the size of particles, the micron sizes of particles, and then you're quantifying them. So you're saying, hey, I have a 0.1 to 0.5 micron, and I have less than 20,000 if you want to hit class 1 for that. And then if you see a class 6, when you look at class 6 for particulate, now we're testing your particulate, but we're doing it gravimetrically, which means we're weighing the amount of particulate before and after the sampling. And we're telling you, hey, we have this much weight, but we're not telling you what size it is. What I see in the food industry, well, I've seen class 1 and 2 in the food industry. However, I'm not saying you have to test to a class 1 or 2. Typically what I see in the food industry is either 4, 5, or 6 on the food industry, and that's more than enough. Class 6 is pretty good on the food industry, doing it gravimetrically. When you start looking at class 1 through 5, you're starting to use more precise instrumentation, a particle count machine, very expensive machines, and so which means your testing will be more expensive. However, it's feasible to get to those with the proper filtration. But in the food industry, I see a lot of the class 6 where they're doing it gravimetrically. And then water, when you do your baseline testing, that navy blue column in the middle, based on the drying systems you have or don't have, you're going to see where you fit in here on your baseline, and typically that's where most people set their specification on what they're currently doing. And then on the total oil, if you look at the class 1 and 2, that's actually 2 types of testing. So you have your oil mist and your oil vapor test. And then when you get to a class 1, you're just testing that oil mist in there. And so on the food industry, I'm seeing it. I see it all across the board, 1, 2, or 3 here. And honestly, they're all good based on your risk on whatever you determine to test. But that's pretty broad as well on the food industry. I see, like I said, class 1, 2, or 3 on there. So depending on what you pick there, also different instrumentation on the class 1 and 2. It's 2 different tests because it's an accumulation of those results that have to fit less than 0.1 or 0.1. So it's 2 tests, where when you start getting to the class 1, now it's not. It's just 1 test. So a little bit cheaper on on the pocketbook as well by doing a class 3 there. And then we talk a little bit about ISO 8573-7, which when you put that -7 in there, that's where it specifically talks about mold and bacteria and yeast in there. And so if you look at these first 3 parts, the 2.4, 0.8, 0.1, 0.2, and 0.3, that's where SQF is talking about the environmental testing in it and what risk base are have to test, and not only have to test, but they have to see, you need to know how much of that bacteria is in your air, and then identify what that bacteria is in. And that's just because you need to know what's in your facility in those different parts, the bottling, the packaging, or what's on your tables, or what's floating in your air. And then below is where 8573-7 talks about what kind of equipment you can use. And so that some of that is depending on if you're doing active testing or active monitoring or passive monitoring. When you talk about active monitoring, that's instrumentation, kind of like what it talks about here on the partial flow slit samplers, where you're actually blowing air through something, through some part of a machine, and then you're able to get flow on a plate. And then whenever you talk more about passive monitoring, you're talking more about settling the plates on the tables. You put a plate out that grows bacteria, mold, and yeast on a table for typically 10 to 15 minutes. And then as these particulates in the air settle down, they will settle on these plates, and then you're able to see how many colony forming units you have in that specific room. And then you're also able to identify them and say this is what the bacteria or the yeast or mold in these out of these spores is. And so you're able to identify them, which then in turn you're able to say, hey, this is acceptable in this area of the facility based on your risk, or it's not acceptable, and then you can come up with some kind of clean in place procedures in your facility to help alleviate the different types of organisms you potentially might see, or the number you see. And then how much particulate water, total oil, mold, bacteria is allowed. The simple answer is SQF doesn't tell you how much you can have. That's for you to determine. But you need to know those risks, right? So you want to know what you have, and that's where it comes in while you're testing at least annually, but maybe quarterly or semi-annual. And then I wanted to give you guys an example, since we talked about baselining, creating a baseline compared to what you're probably going to set up once you create that baseline and do that validation. So this report on the left is a baseline. This is what you're testing, and it's just results. So this is different gases: oxygen, nitrogen, CO, CO2, your water, your oil mist. And the reason I added gases on this baseline, and some food customers are doing gases, is because, like I told you guys earlier, your compressed air is a reflection of the ambient air you're breathing, or the ambient air around that compressor that's compressing the air. So it's important to know what gases are in your facility. If you're breathing the air, you're probably good on oxygen and nitrogen. Oxygen is typically 20 to 22%. Your nitrogen is 75 to 77%. So if you're breathing the air, and you're probably good there. But what you want to kind of look at too is your hydrocarbons, your methanes, because some of these facilities are open bay. They have forklifts. They have heaters going on in the facility. And so if that's happening and your compressors nearby or in the room next door, you might have higher levels of those gases, which could be harmful to your employees, or maybe even on your product, because it's compressing it and you're blowing that air on your product, and it'll cause inconsistencies. We see like higher levels of methane, higher levels of CO2, typically during the winter months when bays and doors are closed, because the air is not able to escape. But that's important to know as well. And then if you look at the right, the report on the right-hand side, that's a report that gives you, once you create that baseline or you have that specification in-house, that's what a report looks like. So you're going to see, the analytes you're testing, along with the results of that testing. You're going to see the specification limits that you've created, and then you're going to see a pass or fail. And this is what I think everyone needs to strive to, is having a specification, because if you're just looking at numbers and results and you're not plotting them out, you're going to just look at them and say, oh, maybe this looks good. But if you're able to set that specification and actually have a hard pass or fail on there, that's going to really be able to help put your eye on consistency, and knowing, hey, I created this specification based on my baseline. So if it's a year or two later, and I'm seeing a failure, well, now I need to go back and see what has changed in the last year or two. Is it filtration? Is it degradation of piping? Have we added more equipment that can cause this, while the air is being compressed? But it's going to give you a light, because now you're going to see that pass or fail. And by seeing that failure and you're actually seeing it on your report, it'll just help point it out to you and your team, so you can go back and look. Hopefully that's not the case, and you're always seeing passing and you have consistent air, which I see in probably 95% of the food industry. There's not a lot of failures once they set up their baseline, but it does happen from time to time. So that'll help spot that out for you guys.
I can give you a bit of an extreme example where I know a business that was cutting and packing cheeses, and all of a sudden they were getting mold growth and shelf life issues and so forth. And I couldn't work out why. Nothing had changed in their operation, but actually directly next door there was a milling operation had started up. We're using some flours and so forth. So that was actually having a direct impact on their product. So it was a significant issue.
I've seen it. I've seen the moisture where it happens, where they, companies have two compressors, and so they'll go, maybe one day they use A, then B, they're using B. Well, then for some reason they just stay on the same compressor and they get off track on switching back and forth, and then they weren't using that valve that we had talked about earlier about draining the moisture. So the day that they pulled the sample, they were testing the other compressor, which I would say you always want to test both compressors, or using two compressors at the same points of use to make sure it's consistent air. But they didn't change out the valve. The water had been sitting there for 6 months in these tanks, because they were just using the other compressor, and they had major problems down line. So yeah, definitely want to test them. And then this is what a mold and bacteria report looks like. It'll tell you, what you're testing, hey, bacteria, mold, or yeast. But then it's going to give you some raw counts, identifying it, and then the results on your colony forming units. It's one thing to do ambient air and you have it on a settling plate, but when we're talking about compressed air mold and bacteria testing, you really want to find equipment that's tested in line. And what I say in line means is this equipment hooks up, so your compressed air the equipment hooks up to the compressed air line, and there's no air coming out of your points of use onto a plate. What I've seen a lot on the compressed air is they'll blow the air out of your point of use. They'll put a plate over here, and they'll blow the air onto a settling plate, and then they either have positive or negative on that plate. The problem you have there is you have ambient air in between where the air comes out and where it's hitting your plate. There's ambient air here in between. So if you have a positive here, you don't know if it's from the ambient air in between or it's actually coming from your compressed air that's hitting that plate. And so you get a lot of false positives and false negatives that way. And so you want to find equipment that hooks up in line to your compressed air. That way you don't have any of that fake positive or fake negatives. Or you're just spinning your head on why this is happening and having to spend a lot of time when it's really not, because it's because it's the air in between. Most facilities in the food industry, you don't have sterile air. I mean, we all have particulate. The air we're breathing right now, there's particulate in the air. There's bacteria in the air. So if you're doing something like that, you're probably going to get a positive, and it might not be from your compressed air. And this is just the type of the equipment that we use at TRI. You're able to hook everything into a 1/4 inch MPT fitting. into your line. We have a gauge that, if you look at this flow section, there's a gauge, and that's based, everything we give you for instructions. They're written instructions along with pictures, and we have videos online. You're able to determine how long you need to run it, and we give you the charts as well based on that pressure on that gauge. We have orifice plates, so that helps, depending on your compressed air, able to determine the amount of air that needs to be flown across the filter for particulate, the water, or the bottle for your gases.
So this would connect up directly to your compressor to make sure, as you said before, you're not getting that environmental air. It's just what's in the line.
That's correct. It'll connect right into your compressor, the lines, and then the points of use.
I want to touch on, Jonathon, if you don't mind. I just want to touch on, maintenance. And we did speak about this earlier, but prevention's better than cure. And again, the SQF does cover off repairs and maintenance and preventative maintenance and so forth. But I get, for me, and it's really interesting, some of the points you make around knowing your equipment, your validation to setting it up to make sure you've got those what the cutoff points are, what's good, and then what it needs to be going forward. But really tying in with the maintenance program for the setup of the equipment, purchasing the equipment, for what's the right filtration, and then changing filters. I think that knowing and being armed with some of this information, either as a working in industry or as a consultant or as an auditor, the regulator, knowing some of these things can have a big impact on product safety and quality, really important. So I guess my point is, I cannot stress enough the importance of making sure you're working and tying in the maintenance program to help prevent some of these things from happening as well. Anything you wanted to add on maintenance, mate?
No, I think the biggest thing on the maintenance side of things, and I know we're almost done with this, is just making sure you're using validated methods and laboratories that are accredited, and using calibrated equipment. What I've seen, especially out here in Australia and New Zealand, is there's a lot of testing being done with tubes, which there's nothing wrong with using tubes, but they're not accurate or as accurate as some of the equipment that's being used in laboratories or laboratories. The plus or minus on moisture tubes for gases, moisture, specifically gases, is very off. Where you can use equipment on like GC mass specs, GC FIDs, and PDIDs. That's going to get you a very precise, very accurate result. And those are mostly found at accredited laboratories. So make sure that, however you're testing it, those are validated methods, and you're using accredited laboratories, because when you use an accredited laboratory, that they're ISO 17025, they're ILAC laboratories, and they have validated methods, but they also have calibrated equipment and trained personnel. So you're getting good results and consistent results. So that's the only thing I would say whenever you're doing repair and maintenance and you're doing this testing.
Excellent. Once again, those guidance documents are freely available if you're looking for further information. But likewise, just as importantly, if you have any further questions, discussed today, please feel free to reach out to either Jonathon or myself. So JSAUSEDA at airtesting.com for Jonathon, and D Alexander at sqfi.com. Any questions? Happy to help support. So no such thing as a silly question. So thank you, Jonathon, for today. Greatly appreciate your input. I've learned a few things. So it's been great. Hopefully this is beneficial to our audience. And thank you, everyone, for joining us from around the world. And we'll look forward to seeing you next time. Thank you.
Thank you.